Okay, so here we're going to learn about what a derivative is. So we're all familiar with what a function is, alright, and we might write this as fx or y. So it might be, for example, the function might be y equals x squared, and you also might see fx equals x squared, means the same thing. This is our base function, okay, and if we were to graph this function, it's going to look something like that. Now the slope function, also known as the derivative function, okay, we call f dash x or dy on dx. And what this is this is a function that allows us to find the slope for any value of x. If we look at the function y equals x squared, okay, we can see that the slope, the rate of change at this point, is going to be different than the slope at this point, and is going to be different than the slope at this point. Okay, so we can calculate the slope function, and the slope function we can use to calculate the slope for any value of x. So let's do an example. The formula we use to find the slope function, okay, is now we need to limit first. Limit as h approaches 0. So we're using a generic value h. F of x plus h, take away f of x, divided by h. So let's do, for example, what we've done here, the function y equals x squared. So our first step is going to be to put x plus h everywhere there is an x in this function. Now we need to include our limit each time as well. So we've got a limit as h approaches 0. We have x plus h squared. Okay, this is this part here. We've got the function of x plus h. We've put x plus h everywhere there's an x. Then we just need to take away fx. Okay, and of course fx is just x squared. Okay, and fx is just x squared, and all this is on h. Now let's expand. So we're going to have the limit as h approaches 0 of x squared plus 2xh plus h squared. Take away x squared, divided by h. We look to simplify. Okay, we can see here we've got x squared and minus x squared, they cancel, so we're left with limit as h approaches 0. We're left with 2xh plus h squared on h. Now we're going to pull h out as a common factor from the top, so we've got 2x plus h. If we were to expand this, we would get what we've got above, and that's all over h. Okay, and we've got h at the top, h at the bottom, that can cancel. So the limit as h approaches 0 of 2x plus h, okay, now h, this part here is approaching 0, which means our answer is 2x. So the slope function of, if fx equals x squared, then f dash x equals 2x. So we can find the slope on x squared for any value of x. So say we want to find the slope at x equals 2, or f dash 2. This is the slope when x is equal to 2 of the original function y equals x squared. So what we're going to do is put 2 into the slope function. This is going to be 2 times 2 is 4. So the slope at x equals 2 is 4. The rate of change of y, according to x, y increases by 4 units for every x unit at x is equal to 2. It's the instantaneous rate of change. So this is a brief introduction to what a derivative is and how we can find it using first principles.